In this tutorial, I will be solving this paper. That's 9709, October, November, then paper 3, variant 1, 2022. So actually follow me. If you're revising on your side, you can just follow up what I'm doing, and then you're going to be assisted instantly. So let me draw the curve first. So this was the curve. We had the minimum point to be M. Then this area is shaded. This area is shaded like that. So what do we do as a result? What do we do? Okay. So I will write the question down. The diagram shows, so we can have this part. The diagram shows part of the curve. The diagram shows part of the curve. Y equal to 3 minus x. Then we have e to the power of negative 1 over 3 x for x greater than or equal to 0. And the minimum point M. The minimum point M. Find the exact coordinates of M. You need to find the exact coordinates of M. So find the exact coordinates of M. So what do you do when you're asked to get the exact coordinate of M? You know, first of all, they've told you like that's the minimum point, and then for the minimum point, these are the points of extremum. So you have to know that dy over dx has to be equal to 0 for any minimum point. So we'll have to differentiate this function y equal to 3 minus x e to the power of negative 1 over 3x. So let's differentiate it quickly. Here we're going to use product rule because you can see there are two functions which have been multiplied together, and each of them they are functions of x. So to get our dy over dx, it will be the same as we take the first part, that is 3 minus x, we differentiate, we multiply by the second part, which is e to the power of negative a third x, then plus we have the first part, so we are not going to differentiate it this time, and then we multiply by the second part differentiated. So this is going to give us negative x e to the power of negative, not negative x. When you differentiate negative x, what do you get? We actually get negative 1 multiplied by e to the power of negative 1 over 3x. Differentiating a constant gives us a 0. That's why I've ignored it. So we are not going to have it there. So this one will be plus 3 minus x. So we are going to differentiate this. This is going to give us e to the power of 1 over 3x. Then we pick this argument over there. So that is 1 over 3x. Then we differentiate it. So you're going to have the function e to the power of negative 1 over 3x, then plus, this is going to give you, when you differentiate this part, you're going to have negative 1 over 3 into bracket 3 minus x, then e to the power of negative 1 over 3x. Now let's solve it. So we can have e to the power of negative 1 over 3x into, this is a 1, this is minus 1 over 3 into 3 minus x, and this is going to give you what? If you work out this one in your calculator, you're going to have e to the power of negative 1 over 3x into bracket, this 1 minus 1, you know, a third of 1 is a third of 3 is 1, and then you're going to have plus 1 over 3x. So what are you going to have as a result, as your answer? So you will have 1 over 3 x. So this one is going to give you 1 over 3x. Okay, just a minute. There's something that we made as an omission somewhere. Okay, this is a minus, yeah, negative. So we should ensure that you're also carrying it forward. So this is going to be minus. So you're going to have minus 2, then plus 1 over 3x. So what are you going to have as your answer? Okay, this is e, the power of negative of that x. So it will be negative 2. Okay, you can leave your answer like this. I think this one is in the simplified set. So let's determine the value, the coordinates of the minimum point. So we'll equate this one to 0 so that you can have 0 equal to e to the power of negative 1 over 3 x into bracket 1 over 3 minus 2. Like that, 1 over 3x minus 2. So what are you going to have? We're going to have e to the power of negative 1 over 3 x equal to 0, or 1 over 3 x minus 2 equal to 0. You realize that this part, to solve for the value of x, you have to introduce natural logs, and you don't have the natural log for 0. So this one does not exist. So we are going to discard that. So we are going to have 1 over 3 x minus 2 equal to 0. So what you have to do, you will take 2 to the other side, and then you have 1 over 3x equal to 2. Then you multiply everything by 3, which is giving you the value of x as 6. Already we have the value of x. Now it's the time to look for the value of y. And the equation that's going to give us the value of y is the original equation of the curve, which is y equal to 3 minus x. Then we have e to the power of negative 1 over 3x. So let's substitute y, it will be 3 minus 6, then e to the power of negative 1 over 3 times 6. This gives you negative 3 e to the power of negative 2. Now, the coordinate that is required for m is 6, negative 3 e to the power of negative 2. They ask you to get in the exact form. So this answer is in the exact form. So let's solve part B. Now in part B, you are supposed to find the area of the shaded region. So find the area of the shaded region. Find the area of the shaded, and the area of the shaded region, and the area of the shaded region bounded by the curve, and the x-axis, bounded by the curve and the x-axis, giving your answer. In terms of E. So what do you have to do with that? Remember, you've been given the equation. You've been given the equation to be y equal to 3 minus x, and then we are going to have e to the power of negative 1 over 3x. So how do we get the area of the region? Now, I'll sketch the diagram so that at least we have a clue of what we need to do. So this is what you're going to have. So this is our diagram like that. So this is the region. We have to get the coordinate of this point here. And how do you get the coordinate of that point? How do you get the coordinates of that point? So the coordinate of this point is the y. Okay, we are going to substitute 0 for the presence of y because we are looking for the x-intercept. So it says 0 equal to 3 minus x e to the power of negative 1 over 3x. And this is going to give us, we can equate either. So 3 minus x can be 0 and x can be 3, or you can say e to the power of negative 1 over 3x, which is equal to 0. When you introduce natural logarithm on both sides, this one tells us that it does not exist. So the x coordinate of this point is 3, 0. So in other words, you need to get the integration from 0 to 3 of our function, which is 3 minus x, then e to the power of negative 1 over 3 x dx. Now let's get our indefinite integral. That is x minus 3, not really 3 minus x. Let's get our indefinite integral. That's 3 minus x and then e to the power of negative 1 over 3x. So what do you do in this case? Now we have to use product rule, because these ones are already not product rule. We are going to use integration by parts, because these ones are the two functions. So what do? You know, like when you are given uv, when you are given this function to integrate, when you are told to have vd u, okay, sorry, integration of u dv. This is giving you uv minus integration of v du. So what do you have to do in this case? We understand the behavior of the exponential functions. When you integrate them, like they're not going to give us problems. So we can just decide to let them to be dv. So we'll say let our u to be 3 minus x du over dx. Du over dx is giving you negative 1, and so the value of du equal to negative dx. Now already we are progressing well. So our dv must be equal to e to the power of negative 1 over 3x dx. So we can integrate on both sides, and then as a result we are going to have v equal to, this one is going to give negative 3 e to the power of negative 1 over 3x. So for this case you can have our u and then v. So our u is 3 minus x, then our v, it's this one here, which is negative 3 e to the power of negative 1 over 3x, minus integration of our v, which is negative 3 e to the power of negative 1 over 3x, then du, in this case our du, it will be negative dx. So what do you do when you have such a scenario? We are going to have negative 3 into bracket 3 minus x e to the power of negative 1 over 3x. This is a minus minus minus. So if there are 3, so it will be minus. Then 3 times, we are going to have e to the power of negative 1 over 3x divided by negative 1 over 3x derivative, and then plus c. So now the answer that we're going to have is negative 3 into bracket 3 minus x e to the power of negative 1 over 3x. This is minus minus, it's going to give us plus. This is 1 over 1 over 3. So 3 over 1 over 3 is going to give you 9 e to the power of negative 1 over 3x, and then plus c. So let's do something with this one. Negative 3 times 3 is going to give you negative 9. Negative 9 times e to the power of negative a third x, you're going to have e to the power of a third x. This is going to give us plus 3x e to the power of negative 1 over 3x. Then plus, this is a 9. 9 what? Here we're going to have e to the power of negative 1 over 3x, and then plus c. Okay, let's find out if there exists any problem when you are solving this. Let's find out. So this is -9. Okay, I think our solution is okay. So we have to substitute our limit so that we can get our definite integral. So if you substitute 3 in this case, you're going to have negative. Okay, this one already it has solved. So this is my -9 e to the power of -3x. If you will check it carefully, you're going to have 0. So in other words, you're going to have 3x e to the power of -1 over 3x plus c for the interval 0 to 3. So let's solve it. This is going to be 3 into bracket 3, then e to the power of -1 over 3 times 0 minus into bracket, this is a 3 times 0 e to the power of -1 over 3 times 0. So this is giving us 9 e. Okay, I'm sorry over here, so let's correct something here. This should be 3. We are substituting this 3. This -1 minus this is giving us a proper 0. So the answer has to be 9e to the power of -1 square units. Huh? Or you can prefer to give your answer in this form. That's a negative, that's 9. So you can get something like -9. I don't know, this one came to be a straight line. So it has to be 9 over e square units. So whichever the form that you want to give your answer, actually, it will give you the same solution. Thank you. That is question 9. So in the next slide, on the next tutorial, I'm going to teach how to solve question 10. Thank you.